Hey everyone, it's Mr. LaCour. Today we are going to go over finding the surface area of a prism or a cylinder. So when I talk about a prism or a cylinder, those are 3D shapes that have what we call two bases. Okay, and I'm going to draw some here, that way you can actually see what they are. So there's three types of 3D figures that we're going to talk about. Two of them are prisms, and one of them is a cylinder. The two prisms that we have, the first one that we're going to talk about is a rectangular prism. Okay, and when I draw that one, we're just going to draw a rectangle. Draw the best rectangle you can. I'm going to use my magic pen to help them draw them really well. And then I'm just going to draw the same rectangle a little bit offset from it. Okay, so I'm going to draw it right here. And hopefully it ends up being about the same. Then what I'm going to do to be able to draw the 3D figure is I'm going to take the corners and I'm going to connect them. Okay. And there you have, and then this bottom one you can do a dash line kind of showing it's behind it. So there you have a 3D prism of a rectangular prism here, okay? And when I talk about different things about it, okay, it has, I want to talk about the vocabulary around it, all right? So I want to zoom in on this picture and we're going to color it in a little bit, okay? So when I talk about the bases, that's the bottom and the top. Okay, so these guys have two bases. So the bottom here of my 3D figure is a base, and so is the top. Okay, now with a 3D figure, we're given 3 dimensions. So I want to kind of talk about what these dimensions are called. Okay, so the line that goes straight up and down that connects the two bases, that is our height of our prism. Okay, now for a rectangular prism we have a length and a width. Okay, another name would be for a base and a height. For the sake of the 3D figure, I'm going to use a cursive L for the length. Okay, so my L is right here, and my W for the width. Now in a formula later on, you might come across something that says B times H. That's the same thing as length times width. Okay, so just kind of be careful about that, and we'll kind of go more into it. All right. So those are the parts of the rectangular prism that we would need to talk about and identify. Now the next shape that we're going to talk about is a triangular prism. Okay, and this one is very similar as well. Instead of drawing a rectangle, I'm going to draw a triangle in the front using my magic pen. Okay, and then I'm going to draw the same kind of triangle a little bit further back. And then I'm going to connect the corners. Okay. Okay, so there we have it. We have a triangular prism. Now, this one, it's a little different. I don't have a bottom and top. Well, I kind of do, but it's not where you think it where it was on our rectangular prism. In fact, our bottom and the top is in the front and the back. Okay, so think of the bases as somewhere where you can set it down on a table and it'll be the same shape on the top. Okay, so a rectangular prism, we can actually kind of set it down multiple different ways and it'd work out that way. A triangular prism, not so much. It'll be a corner at the top, or the bases on the sides, things like that, okay? So kind of watch out for that. So a triangular prism, let's talk about its dimensions. Okay, so if I get this guy, so when I said the height was connecting the two bases, that's this guy. Okay, in this case it's the height. Okay, now there's a different height that I want to talk about. All right, in a triangle, finding the area of a triangle is base times height. Well, there's a height of the triangle. I want to do it right here. So it goes from the top vertex down and it makes a 90-degree angle. And that's my H. I want to use a cursive H to kind of identify that one. And then a little b for that base, okay, of the triangle. All right, and then other sides of the triangle we'll also use later on, but for the main dimensions that we need for this. Okay, one more shape that we're going to talk about is a cylinder. Okay, a cylinder is another type of prism, except that it is in the form of a circle. So I'm going to draw kind of a circular pattern here, and then I'm going to draw some lines going down, and then I'm going to draw that same kind of circular pattern there, and if it doesn't fit quite right, you guys can probably draw better than I can. There you go. That's as good as I'm going to get. Okay, so there's my cylinder. It looks kind of like a can of soup that's kind of tilted a little bit. I'm not the best drawer. So some information on the cylinder. Okay, as we talked before, our bases were the circles down here. Okay, so where I can set it on a flat piece of table or something. Now I have the height connects my two bases. That's right here. That's my H. Okay, and then there's one more important thing. From the center of the circle to the edge, we're going to have a line. That is our radius. Okay, we're not always given a radius. Sometimes we're given a diameter. A diameter, I want to show you real quick, goes from one end all the way to the other. Okay, that is the diameter. They'll use a D for that. What you do if you're given a diameter, you're going to divide that by 2 to get your radius. But hopefully we won't have to deal with that, and we'll just have the R's. Okay? All right. So now that we kind of know what the three shapes that we're going to be talking about are, their dimensions, and what their base shapes are, that can help us find out the surface area to them. Okay? So when I talk about surface area, okay, surface area is how much space is needed to cover, okay, cover the shape. So surface area, we are given two formulas, okay, one for a prism, one for a cylinder. So the prism formula is S equals capital P times our height plus 2 times a capital B. Okay, and our cylinder, that one's pretty close to the same thing, except that it's got a little bit different thing since we're dealing with the circle in there. Because we're dealing with a circle, we're going to use the Greek symbol pi. So to find the surface area of a cylinder, 2 times pi times our radius times the height, oops, don't know why I wrote that, times our height, plus 2 pi r squared. Okay, so those are our two formulas that we have here, and we'll use those to find our surface areas. Okay, and I'll kind of go into what these things mean. All right, so a little side note for the prism. Okay, capital P stands for perimeter, and capital B stands for area of the base. I should explain the P a little bit more too. It's not just the perimeter of the entire shape. We're not adding up all the sides. We're adding the perimeter of the base. Okay, so we're focusing on the base there. All right, so our first picture that we're going to deal with is a rectangular prism. So let's kind of go to a new page. So number 1, rectangular prism. go ahead and draw one out. Okay. Do the best you can to make them the same. If it doesn't line up perfectly, that's okay. All right, and let's go ahead and give it some dimensions. I'm going to label this 3, 6, and 6. Okay, my bases. So the dimensions that I want to use, or what I want to use as my base, is the bottom here. Okay, so just like before, the bottom is my base. I just want to focus on one base right now. Okay, I don't need the other one just yet. All right, so things that I need for my formula. My formula was capital P times H plus 2 times capital B. Now, to find the area of my base, okay, the blue part, all right, my capital B equals 3 times 6, which gives me how much? Type in your calculator, you should get 18. Okay, now that value we're going to take and plug back in. For our perimeter of the base, I need to find the distance all the way around. So if I know that those two sides of the rectangle are 3 and 6, how much is this part up here? And then also how much is this to the left? We're going to go ahead and label them. This is 3, since it's the same as the front, and this is 6 since it's the same as the right. So what we're going to do is we're going to add all these up together. So 3 plus 6 plus 6 equals a total of 18. Sorry about the writing there. Okay? So we have 18 for the base, area of the base, and 18 for the perimeter of the base. So what I'm going to do is I'm going to take those values, I'm going to plug them into our formula. So I'm going to back over here, S equals, so that capital P was 18. Now that H, I need the height of the prism. Okay, well that value is this 6 right over here. So I'm going to take 6 and I'm going to multiply it by the 18. Equals, plus 2 times the area of the base, which was also 18. Okay, so now we take our calculator. Oops. If I can figure this out. There we go. So, type the whole thing in there. 18 times 6 plus 2 times 18. We get a surface area of 144 square units. Okay, our units will always be squared since we are finding the area. Okay, cool. So there is our rectangular prism, how we're going to find the surface area of that. Let's go on to another one. Let's do a triangular prism. Okay, so our triangular prism is going to look something like this. So you draw one triangle, and up and to the right you can draw offset. Okay, same kind of triangle. And then you just connect the dots or the corners best you can, okay? Okay, there we go. So the bases that we have, like I said, we just want to focus on one of them for right now. Okay, so I'm going to go on to the front here. And then some values I want to label. Okay, so on a triangular prism, we have some other values here. So I have 4, 5, 5, 5, and then 3.7. Okay. So there's a lot of information in here. There's more numbers than usual than what we did with that rectangular prism. Okay, so we're still using the same formula. So S equals capital P times H plus 2 times capital B. All right, our capital B, to find the area of our triangle, is base times height divided by 2. So the base of this triangle is right here, which is 4. And then the height. Oops. Okay, this is the part that I want you guys to focus on. The height here is the height of the triangle, not the height of the prism. So the triangle height is right here. That value we labeled 3.7. So I'm going to take those two values and I'm going to plug them in here. So I have 4 times 3.7 divided by 2. So I go over to my calculator, I hit the divide button if you're using Desmos to make my fraction. 4 times 3.7, and then on the bottom I hit the 2, and then I get a total of 7.4. Okay, now capital P. Capital P was the perimeter of the base, so the distance going all the way around. Let me make this a little bit bigger. So the distance going around, I add up all my sides, so 5, 4, and 5. So I use 5 plus 4 plus 5, which gives me a total of 14. Okay, so I'm going to take those values and I'm going to plug them into my formula. So S equals, my perimeter was 14, times the height of the prism. Okay, so now I got to go back up here. That's the 5 plus 2 times the area of the base, which we said was 7.4. Okay, so now what we're going to do is we're going to go into the calculator and we're going to type it all in. 14 times 5 plus 2 times 7.4. Oops, I didn't get my 7 in there. 7.4. All right, there we go. So my surface area to this is 84.8 inches, or inches squared, or meters squared. I'm just going to give it meters squared. That's how you'll see your answers, okay? Even though we are dealing with three-dimensional figures, we're talking about finding the area, so it is a meters squared or inches squared kind of problem, okay? All right, last one that I'm going to do for you guys is a cylinder. See if I can draw this one better than last time. I'm going to cheat a little bit, actually. There we go. So you draw your two circles and you connect them, and it makes a nice pretty cylinder. Okay, and then I'm going to take my radius and I'm going to label it 13, and then I'm going to label my height 7. Now, some of you are saying, hey, that height looks bigger than that radius. Yes, you're absolutely right, but these things aren't drawn to scale, so never trust a picture of how it looks. Always go for the numbers of what it should be. Okay, so for our cylinder, we use a different formula. Okay, in a way, it is actually the same. You just have to understand that what the perimeter and the base formulas are of a circle are, but we just use this formula, 2 pi r, which is actually the circumference, times the height, plus 2 times pi r squared, which is pi r squared is the area of a circle. So we're still doing the perimeter and the area of the bases. It's just in the form of circles. All right, so what we're going to do is we're going to take all that information exactly as we see it. There's actually no special calculations we have to do. We just have to take those values and plug them in. So that 13 is going to go in place of every single r that we have there. And this 7 here is going to go in place of the h. Now, some of y'all remember pi. What we're going to use pi for is we're going to use 3.14. Okay, it's a decimal number that goes on forever and never stops, right? And there's also pi buttons on your calculators. Not everyone has a calculator that can do that, so that's why we're just using 3.14 for pi. So when we rewrite this, it's 2 times pi times my radius, which is 13 times 7 plus 2 times pi times 13 squared. Okay, and what that's going to look like over here in our calculator. 2 times, and we said we're going to use 3.14 for pi, so 3.14 times a radius, which is 13, times the height of the cylinder, which is 7, okay, plus 2 times 3.14 times 13 squared. Now that squared doesn't mean we just type a 2, all right? You type that little 2, the x squared or a squared type looking number. So mine is on the left over here. I'm going to type that and I get my squared up there. Now I get this really big number. Yes, that's okay if you get a really big number. We will deal with a lot of those. Okay, but I also have a decimal. Give me that one decimal place, round it correctly if you need to. If your calculator gives you more decimals, make sure you're rounding correctly. Mine gave me the 1, so mine is 1,632.8 units squared of area. Okay? Well, that concludes everything about finding the surface area of prisms and a cylinder. Hope you guys have a great day. If you have any questions, find me on WebEx or email me. I will talk to you guys later. See you. Love you. Bye.